Hello everyone, Mr. Linder here. Let's talk about the general functions of the respiratory system. So what's interesting about the human respiratory system, and that includes all terrestrial multicellular animals, is that we have to have a large surface area to meet the oxygen and carbon dioxide requirements for aerobic metabolism. But we also have to protect the respiratory system from dehydration. So, multicellular terrestrial organisms have to place their lungs deep inside of a protective cavity. So, if we look at the anatomy of the respiratory system, you'll notice that the lungs are housed deep within the thoracic cavity. And so the lungs being inside the thoracic cavity will protect the lungs from dehydration, exposure to the elements. However, it creates a problem for getting respiratory gases in and out of the lungs. So we have to have a system of tubing to allow oxygen and carbon dioxide to be exchanged with the atmosphere. So what we see with the respiratory system is we have the nasal passageways, we have the oral passageway, and then of course we have the larynx, trachea, bronchi, and then of course secondary, tertiary, all the way down into bronchial tubes before we reach the alveoli. And the alveoli are where we're going to exchange oxygen and carbon dioxide. So oxygen in, carbon dioxide out. So we have this unique respiratory problem because of the internalization of the lungs. And so the question becomes, how do we really move air between the atmosphere and the lungs if our lungs are deep inside of a thoracic cavity? And so the answer to that becomes a muscular pump system. So when looking at the physiology of the respiratory system, we really have to talk about how we use the diaphragm and other muscles to move air in and out of the respiratory system. So the primary function of the respiratory system is to exchange respiratory gases between the atmosphere and our blood. And so there are several terms that we look at when we describe how the respiratory system works. One of the main terms we want to define is this term called ventilation or breathing. And ventilation is really talking about how do we use the muscular pump? How do we use our diaphragm and our intercostal muscles and our scalene muscles? How do we use musculature in order to breathe, in order to ventilate? So really ventilation becomes a mechanical process. And so ventilation is the mechanics behind inhalation and exhalation. And inhalation is really just talking about how do we bring respiratory gases into our lungs so they can be exchanged at the level of the alveoli. So how do we inhale oxygen? And exhalation is really talking about how do we exhale carbon dioxide. And we'll look at that in more detail in future videos. So the term ventilation or breathing really is just talking about the mechanics of inhaling and exhaling, predominantly using our diaphragm muscle so that we can bring oxygen into the alveoli and then remove carbon dioxide from the alveoli. And we need to bring the gases into the alveoli so that we can exchange with the blood. So this is a nice anatomical diagram just showing you capillaries surrounding the alveoli deep inside our lungs, which of course are deep inside of our thoracic cavity. So that's one of the main functions of the respiratory system is breathing or ventilation. Another important concept to look at when we talk about the respiratory system is the idea of external respiration. Once you have respiratory gases in the alveoli, obviously carbon dioxide we're going to talk about leaving the respiratory system. But what about the oxygen that has come into the respiratory system? So oxygen has entered into the alveoli, and we want to get that oxygen into the cardiovascular system. So we use a term called external respiration to talk about how we move respiratory gases between the alveoli of the lungs and with pulmonary circulation, or the capillaries of the cardiovascular system. So external respiration is exchange of gases between alveoli of the lungs and the pulmonary capillaries. So carbon dioxide is returning through the pulmonary system, and so CO2 is going to leave the pulmonary capillaries, and then oxygen is going to enter into the pulmonary capillaries. And again, this is referred to as external respiration. Another thing to look at, though, when we look at the respiratory system is how do we actually transport gases within the cardiovascular system. So the simple answer, and then we'll look at this in future videos, is that oxygen is transported associated with hemoglobin. So we have hemoglobin in our red blood cells. Sorry, I miswrote that. We have hemoglobin in our red blood cells, and we attach oxygen to that. So hemoglobin attached to oxygen is our primary way of moving oxygen through the cardiovascular system. Carbon dioxide is a bit more complicated. Some carbon dioxide is transported attached to hemoglobin, but actually the bulk of our carbon dioxide is transported in the form of bicarbonate. And so in future videos, we'll talk about how to produce bicarbonate and how we move bicarbonate through the cardiovascular system. So that's gas transport. A third concept to look at with the respiratory system is internal respiration. Internal respiration has to do with exchanging respiratory gases between the systemic capillaries and our body tissues. So internal respiration. So in this situation, we're talking about oxygen leaving the circulatory system and going into our tissues. And then carbon dioxide that's produced through cellular respiration, we're talking about CO2 leaving the tissues and going into the systemic capillaries. So this would be referred to as internal respiration. Oxygen enters into our tissues so that we can use it in cellular respiration. We use it as the final electron acceptor in the electron transport system. And this allows us to produce our maximum amounts of ATP through cellular metabolism. So the final concept to discuss really with the respiratory system is this idea of cellular respiration. When oxygen enters into tissues, we're going to utilize that oxygen in order to generate ATP and then use that energy for cellular function. So when looking at the respiratory system, we not only have to talk about breathing, but we have to discuss external respiration, gas transport, internal respiration, and then, of course, the idea of producing ATP through cellular metabolism. Some other functions of the respiratory system would be maintaining pH balance. It's important to understand our carbon dioxide balance within the body. So this is an important equation to memorize. CO2 in water becomes carbonic acid, H2CO3, and then that can dissociate into hydrogen ions and bicarbonate. So plus bicarbonate. This is an enzymatically catalyzed reaction. The enzyme is called carbonic anhydrase. And if you understand this equation, you can understand how the respiratory system influences your pH balance. So when there's hypoventilation, so when we breathe less, hypoventilation leads to an increase in carbon dioxide levels, which is going to shift this equation to the right, which is going to result in increased hydrogen ions internally, which will lower our pH, and we would refer to this as acidosis. So hypoventilation leads to acidosis. If we have hyperventilation, so if we adjust the respiratory system in order to breathe more rapidly, hyperventilation, we're going to decrease the amount of carbon dioxide. That's going to shift this equation to the left, and so we're going to have decreased hydrogen ions. As those hydrogen ions combine with bicarbonate, we're going to get more carbon dioxide to replenish the CO2 that we're blowing off. So hyperventilation decreases CO2, so we need to make more CO2. That thus decreases our hydrogen ions, which will increase our blood pH and lead to alkalosis. So we can use hypo and hyperventilation for homeostatic balance of pH. Another thing to consider with general functions of the respiratory system is using the respiratory system to protect ourselves against inhaled pathogens or any inhaled irritating substance. Most of the inhaled pathogens and inhaled substances are going to be trapped by mucus in the respiratory system. So if we take a look at the respiratory system, you can make note of the type of epithelial tissue. This is pseudostratified ciliated columnar epithelium. And in that pseudostratified ciliated columnar epithelia, you will also find goblet cells. And those goblet cells produce mucus, so we can see all of this mucus here. And those goblet cells producing mucus is going to allow for particulates, right, to be trapped, and that's going to then be pushed by cilia out of the respiratory system, and is going to provide protection against these inhaled pathogens or harmful substances in the system. Another function of the respiratory system is vocalization. So using the respiratory system for vibrations to create speech in order to sing or any other sort of communication that can be used. So air moving across vocal cords is going to be important in creating those vibrations that we use in speech. Some other things to consider when you look at the respiratory system is to understand the airflow through the respiratory system. What's interesting is that airflow follows the same physics properties that blood flow follows. So if you're familiar with delta P pi r to the fourth over 8L eta, this is Poiseuille's law. If you're familiar with that law as it relates to blood flow, you can simply use it to describe airflow as well. So what are some things that affect airflow through the respiratory system? Well, air will move when there's a difference in pressure. So if we can create a delta P, a difference in pressure, then air will move. So basically what we're saying is that if there's a high pressure and a low pressure, then air will flow from the high pressure area to the low pressure area. So if the atmosphere has a higher pressure and the alveoli of the lungs is at a lower pressure, then we can get air moving into the respiratory system, and that would be inhaling. And we're going to use a muscular pump to do that. If the pressure is greater in the alveoli, so if we have high pressure in the alveoli compared to a lower pressure in the atmosphere, then air will flow out of the respiratory system, and that will be an exhale. And so we can use the musculature in order to achieve differences in pressure. So a muscular pump will create the pressure gradients. The primary differences that you see when you're looking at what affects airflow through the system, besides changing the pressure, is to look at the size of the respiratory tubing. And so that's where R to the fourth comes into play. We're really talking about the bronchial diameter. So if we were to increase the radius, so if we are bronchodilating, that's going to improve airflow. If you're going to decrease the radius, then that's going to decrease the airflow through the respiratory system. And then, of course, viscosity or resistance to airflow. So if there was some thickening of mucus, especially during disease states when infections take place, or if you're suffering from conditions like cystic fibrosis, chronic bronchitis, emphysema, COPD type disorders, then of course that viscosity plays a role. And so the thickness of the mucus secretions and saline secretions within the respiratory system will have a negative impact on airflow. There will be an inverse relationship. So as viscosity goes up, then your airflow is going to decrease. So we can use the same physics properties to describe the general functionality of the respiratory system. The last couple things to consider when you're sort of looking at the overview of the respiratory system is what's going on with the air as we breathe it into the respiratory system. So during breathing, the upper airways and the upper bronchi, they're not just passageways for air to flow. Instead, we're actually conditioning air as it goes through the respiratory passageways. So as we breathe air into the nasal cavity or as we bring air through the oral cavity, there's going to be a conditioning of air prior to it going down the trachea and entering the bronchi. And so our upper respiratory pathways are really doing three things to condition the air before it reaches the alveoli. We're warming the air, we're humidifying the air, and then we are filtering or cleaning the air. So when we talk about warming the air, so if we're talking about three things that affect the air as we breathe it in, we're really just talking about bringing air temperature up to 37 degrees Celsius. And this is so that our core body temperature doesn't change. So as you're breathing in cooler air from the external environment, we're going to bring air temperature up to body temperature so that we don't damage delicate tissue in the respiratory system. We want the air reaching the alveoli to not be cold air. We want it to be body temperature air. So you're going to see heat transferred from capillaries that line the respiratory system. The heat that's in the blood is going to be transferred to the air, and that's going to warm the air. So blood vessels essentially that travel along the respiratory system are transferring heat to inhaled air so that it reaches 37 degrees Celsius. Clearly, breathing through your nose is going to be more effective at this process than breathing through your mouth. As you breathe air in through your nose, the air spends more time in your nasal passageways as it circulates around inside the nasal cavity, and so you have more time to warm and humidify and filter the air. To add moisture, we're bringing air essentially to 100% humidity. So that's number 2, to humidify the air that we breathe in. So humidity. So we're adding moisture to the air. And again, this is to prevent any sort of drying out or any sort of dehydration or desiccation that happens to our lungs and the delicate tissues. And so again, water is being evaporated from the mucosal lining and is being added to our airways to provide humidity. The third thing that we see is that filtering process. And again, this is better if you're bringing air through the nasal passageways because again, the air is spending more time in there and it's going to be trapped in the mucus, and we're going to prevent foreign material from reaching the more delicate lower structures of the respiratory system. So we're cleaning out viruses, bacteria, fungi, any sort of organic and inorganic particles that might cause damage to the lower structures of the respiratory system. And we do this through the pseudostratified ciliated columnar epithelium. We do this by trapping debris and mucus that's produced. We produce a saline secretion, and so this is going to protect our delicate airways. And then we're going to use the cilia to transport the trapped particulates out of the lower areas of the respiratory system up into the upper airways. And then, of course, we could swallow a lot of that debris into the esophagus and down into the stomach. So we are using mucus and we're using secretions in order to trap these foreign particles. In order to secrete a saline solution, we actually use CFTR channels. CFTR, actually named for the pathology, cystic fibrosis, transmembrane receptors. These CFTR channels are responsible for moving chlorine into the luminal space. And as we move chlorine into the luminal space, we're also drawing water into that luminal space, and that's going to give us that saline solution in the lumen of the respiratory system. In the pathology of cystic fibrosis, those CFTR channels are damaged, okay, or they're non-functional. It's a genetic, right? It's a genetic defect in the cystic fibrosis channels. It's inherited, and this is going to lead to decreased water and electrolytes into the luminal space. And so that leads to thickened mucus and the symptoms that we associate with cystic fibrosis in the respiratory system. So that thick mucus is hard to clear, and bacteria can colonize, and that can lead to lung infections. That was a little bit on the general functions of the respiratory system. I hope that helps. Take care.